All right, here we go, guys. We got questions. We're probably going to go 11 through 15 here. So you got a linear function fx equals x is graphed on a coordinate plane. It's actually your parent function. It's very similar to the graph y equals x. And we want to think about our y equals mx plus b, what all those different things are, and then maybe we can figure out what's going on from there. We'll look at that here in a second. The graph of a new line is formed by changing the slope of the original line to 2/3, and then the y-intercept, we're going to change that to 4. Which statement is true, or which statement about the relationship between the two graphs is true? Okay, so we want to think about this. Y equals x. As far as your mx plus b, normally your slope-intercept form is y equals mx plus b, kind of like this here. Our m, or that implied number out in front of x, is going to be 1. That's our slope. Okay, that's the slope of your parent function. The b value, you don't have 1, so it's like the same thing as saying plus 0. So now we're going to look through here, figure out which of these options kind of match up. So what do you got here? The graph of the new line is steeper than the graph of the original line. Well, let's look here at our slopes here. So the slope of y equals x, it's kind of like a up 1 over 1 type of graph here. But now we're changing it to 2/3. So it's going to kind of look a little bit different. It's going to go up 1, 2, and then over 1, 2, 3. Kind of like that. So it's a little bit less steep. That slope is a little bit less steep there. So let's see here. The graph of the new line is steeper than the graph of the original line. I disagree with that right there. Okay, and then the y-intercept has been translated down. The y-intercept has been actually translated up here. If we're changing our y-intercept to 4, we're going from 0 to 4. That means you're going up. So both of those are opposite. Let's see here. The graph of the new line is less steep. That's what we want. And the graph of the original line, or then the graph of the original line. And then the y-intercept has been translated up, and that is also true there. So that's looking like a good option. Let's just go through, read through the rest of them, make sure we're not missing anything here. Making a dumb mistake here. The graph of the new line is steeper, so that's good. And the y-intercept has been translated up. Actually, you know what? We just said the graph is not as steep there, so I put a check there on accident, my bad. And then the graph of the new line is less steep. That is true. And then the y-intercept has been translated down, and that part right there is false right there. It's been going up there. So B is definitely our best option. So it's not too bad. You just need to know what the slope of y equals x is, which the slope is 1, the b is 0. Okay, next one, the table shows some ordered pairs that belong to some type of quadratic function. Okay, so quadratic function, you need to know that these are your U-shaped graphs. All right, they're shaped like a parabola. Sometimes they're opening up, sometimes they're opening down. So we're just going to try and sketch what we got here to kind of get an idea of what's going on here. So look at all your y values. You start really big, you're going down, you go to -7, you go back to -8, then you go back to -7, then you go back to 1 here. So it's like it's coming down to this -7 right here. And that's got a, kind of a specific name here. Actually, not -7, comes down to -8. So it's coming in the -8, and then it switches back around here and goes back the other direction. So I'm just going to kind of sketch what I think is going on here. You have 0, 1, so there's your y-intercept. You got 2, -7, kind of down there. You have 3, -8, a little bit lower. But then you go back to 4, -7. So it kind of turns around right there. And then I guess you got 6, 1. So this gives us a shape of one of our quadratic graphs right there. It's kind of our shape right there. And we'll use this point right here, this point where it turns around. That's called your vertex there. That is your vertex. 3, -8. So that's going to help us here answer these follow-up questions. What is the range? Okay, range is all of your y values that exist on this function. All right. By the way, domain, if they ask you for domain is all your x values. Okay, so range is basically asking how high does a graph go and how low does a graph go. Now, since you have arrows, this graph, we're going to assume it keeps going up forever because they only gave us a few points. They said, there's more, but they gave us a few. So we're going to assume this graph goes up forever, but it does come down to a lowest point right there, all right, which is 3 comma negative 8. So we're looking at the y value. So the lowest it goes is a negative 8. So we're going to say y is greater than and actually equal to negative 8. Okay, all y values will be greater than or equal to negative 8. Okay, now if you were talking about the domain, that's kind of like left and right. The graph does go left and right forever, so you would just say everything possible there. So they're trying to throw you off. If you don't know what domain is, the difference between domain and range, you might accidentally choose F right there. F is all real numbers. That's actually the domain in this case. Sorry, sometimes notability. It's kind of hard to write with. So that would be your domain, which is not one of your answer choices there. All real numbers that are greater than or equal to negative 7. That's not it, because we're saying it needs to be greater than or equal to negative 8. This option with 0 doesn't really help us with anything there. Okay, so that means all your values are above negative 8. So you got to sketch it out to figure out kind of what's going on. All right, now this next one here, I worked this with my class earlier. It's a little wordy. There's some little details you got to be looking out for. All it's asking here is which set of equations would help you to eventually solve this with using either your substitution, elimination, or looking for your intersections on your graphs here. Well, all we're doing is selecting the equations here. So this one's kind of tricky, so listen up here. You got a sports magazine. They print 12 issues per year. And then a technology magazine prints 10 issues per year. So that's going to come into play a little bit later. All right. And then the total number of pages in all the issues of the sports magazine for 1 year is 32 more than the total number of pages in all the issues of the technology magazine for 1 year. So I'm going to highlight all of this. This is one of our situations here. All right. So we can write an equation. The key thing we need to look at here is they say this is going on in 1 year. Okay, because when we were working this out earlier here, we were saying, okay, well, what is there more of? There's more of the sports magazine. So we said sports equals the technology magazines. And then, here, I'm going to make that kind of curve there. And then plus 32. But we got to think this is over the entire year. So you got 12 issues per year and 10 issues per year for your corresponding magazines. So we actually need to attach those values there. So you got 12 issues per year for the sports magazine. So I need to attach that value to the sports magazine. And then 10 issues per year for the technology magazine right there. And then over the entire year, there's 32 more of the sports magazines. So we're going to take technology magazines over the entire year, add 32 to it, and that gets you one of your equations. So right away we see a couple of equations that look, oh yeah, okay, yeah, so there's a couple of them that kind of look similar to that. It looks like A's got a pretty good option. Let's make sure we don't mess up the other equation here and see what's going on. So the other one here, each issue of the sports magazine has 18 fewer pages than each issue of the technology magazine. So we're just talking about one issue at a time, so I don't need to attach some type of value. So the sports one has it's the same as the technology after you subtract or fewer, 18 fewer of the technology. So we'll subtract 18 from T. All right, and that gives us option A. Option A is probably our best right there. We don't even need to solve it. We just need to get it set up. But the key thing is in that stuff I highlighted with the blue right there, we're talking about 1 year. So we got to think about the issues per year, which is kind of tricky there. Okay, next one here, 14. What is the y-intercept of the graph? The line graphed on the grid. So if we look here closely, we can't really tell what the the y-intercept is. It's somewhere between 6 and 5. It might be 5.5, but I'm not 100% for sure on that. It could. What if it was, 5 2/3 or something kind of close to 0.5, but not exactly. So there's a couple different ways you can do this. I've had students in the past use regression with 2 points to get the y equals mx plus b, and then figure it out from there. And so that's one way you can do it. What I'm going to do here, I think what they're intending for you to do is use the thing called point slope formula. So that's y minus y1 equals m, and then x minus x1. Alright, so we're going to use those points there and plug them in. But actually what I need to do first here is I need to find my m. Now you can do this with your slope formula, but if they give you a graph, I usually just go and count the rise over run here. So I'm going to count the rise and then over run. Oh, whoops, I didn't go down far enough. Okay, so let's see here. It's going down. It looks like 6 units. So I'm going to put a -6 because I need a negative slope. And then you're going from -2 to 6, so I think that goes over 8. So we're going to say m equals -6 over 8. That does reduce. That's going to be -3/4 right there. So I'm going to just go ahead and start to plug some of this into my point slope formula. As far as the points, I'm going to go ahead and use the one that's got both positives there so I don't accidentally make a little mistake with the signs. So I'll go y minus 1, and then I'll go x minus 6. Okay, and then we're going to go through and distribute some of this here. So we got y minus 1. If you're not sure what 3/4 of 6 is, I don't think it comes out super clean. So I'm going to use my calculator here, 3/4, which is the same thing as 0.75. 0.75 times 6. That does get you 4.5. You got a negative times a negative, so that'd be positive 4.5. Alright, and then we're going to go ahead and add the 1 to get this in y equals mx plus b form. If it's in y equals mx plus b, the plus b part, that is your y-intercept. So that piece right there can tell you a lot about this information. Now this is one of those griddable problems there, so that you don't have multiple choice. So you'll go through, it's got like the grids, and then I think you bubble the 5, and then you bubble the decimal, and then you bubble, like another 5 or something. I think you write it kind of like this. So it kind of looks like that. So somehow, some way, get 5.5 on there. Don't forget your decimal. So, all right, last one here for this video, and then we'll take a break. We got which expression is equivalent to 9q squared minus blah 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 blah. Okay, not gonna read all that out. So anyways, basically they're asking to simplify. Oh, that's right. There we go. Swear sometimes the notability does not want to work with me. So we need to simplify this thing here. We do have a set of parentheses, and we got something outside the set of parentheses. Okay, so that means we got to distribute that. So you're going to have 9q squared minus 2/3 of 3. 2/3 of 3 is just 2, so I'm going to say 2q. Just kind of did that in my head. You can use your calculator if you need. Now you got to go 2/3 times 7. I'm going to do some scratch work over here off to the side. 2/3 times 7, and you can use your calculator if you want. When you multiply that, it'll be -14 over 3. Okay, but actually in this case here is a -7, so actually it should have been +14 over 3. Okay, and then you got plus 5q squared. Okay, now from here I'm going to go ahead and simplify this down here. You got some like terms there. So you got, when you add those, I guess you got 14 of them, 14q squared. And then you got minus 2q. And then you got plus 14 over 3. And hopefully that's one of my answer choices here. Oh, yeah, looks like my answer C. Alright, that is it for this video here.